Hi, this is Mr. Max. So I am continuing with my series on differentiation, and what I'm doing here today is something called implicit differentiation. Now, the um, the general idea here, the general idea here would be, I hope that somehow you have done a bit of work on implicit differentiation. Okay, so if you have something like this, you know that y is not written on its own. It's not y equals to some function of x, but you have got x cubed plus y cubed is equal to 5. So the y is not alone as it is, and because of that, you need to consider that we need a different approach. Now, of course, you can make y the subject of the formula, but some of these equations where x and y are given can be a bit problematic. So let's look at how you would be approaching this. So the first thing that you probably have to do, maybe you will have to write down a few of this, just one or two steps that I'm going to say. So you are going to derive both sides, okay, because this is an equation. So what you do on an equation, on the left and the right still keeps that equation through. So derive both sides of the equation, but we're going to do it with respect to x. So this is going to be d by dx of, let's have x cubed plus y cubed, and that is going to be the same d by dx of 5. Now, I'm not always going to use this whenever I solve, but for the sake of explaining this concept, so you have got different terms which you can actually go ahead and say, well, let's take d by dx of x cubed. So x cubed is already in terms of x, so this would mean you derive like normal. Here I have d by dx of y cubed, and this is where I'm going um, to be spending a bit of time with. So obviously the derivative of a constant is 0. So let's just talk a little bit more about what we got going on over here. Okay, what we got going on over here. Now, because you can see that this is d dx, but you have got y there. Now, let's suppose I give you an example. And in this example, we just change the color. Let's say I say you are supposed to find the derivative of a function like so. Um, let's say it's 3x squared minus 1, and this should be raised to the power of 4. Okay, well, these other brackets were not really necessary, but okay. Um, and the way you will do this is you will be using what is referred to as the chain rule. Now, what the chain rule essentially means is you're going to use that power, and then you're going to multiply with whatever you have inside, and then you're going to find the derivative of that stuff inside. So this is what I mean. So you have the power, so that's going to be 4. Then you have the stuff inside. You reduce that by 1. But then you're going to multiply that by the derivative of the stuff inside. And the derivative of stuff inside, which is 3x squared minus 1. Okay, so this is what you will be doing normally. So now you have that same approach that we're going to do over here. So we are going to say, I'm going to have d by dx of the derivative of the stuff inside, because this is the chain rule. So what you're going to do is going to say derive like you would derive normally, so that becomes 3y square if you were to do that normally. But then you are going to multiply that by the derivative. You're going to multiply that by the derivative of d. Let's just continue with that. D by du. x of y, derivative of y. I hope you understand where I'm going with that stuff. So this is what I'm talking about. I'm talking about the stuff inside. Think of that as the same scenario like you would have something over here. Okay, so there is my power. So I already did that part, but now I'm going to find the derivative of that inside. So essentially, these two statements, right here and the black over there, they are actually the same thing. So let's just clean it up. So we have d by dx of, let's just keep it like this for now, plus. All right, so to clean this up a little bit, this is obviously just 3x squared. Then here you have the derivative of that, which we already calculated. So maybe just to have my notation, just to correct my notation, so I don't mess up, let's just leave that as y cubed. Okay, so that is going to give me 3y squared. But now do you see you have d by dx of y, which is the same thing as dy dx, because the derivative of the stuff inside is d by dx. So that's what you have over here, of course, equals to 0. Now you can actually continue. The second step that you have to remember, okay, after you have arrived at that, the second step that is very vital, maybe before I write that second step, just add a little bit of a note here so that you can remember that every time, every time you derive anything, you derive, let's say you derive y, okay, well, every time you derive y, such a situation, you must get a dy dx, like what I have over here. Okay, you must get a dy dx on account, okay, of the chain rule. Okay, so that is what you need to understand, and you will pretty much see a different question that I'm going to do. The second step, once you have arrived at this, you now have to say solve for dy dx. Okay, it's like make dy dx the subject of the formula. And I like to keep my dy dx behind whatever terms are there. So initially this is 3x squared plus 3y squared dy dx is equal to 0. Then you have 3y squared dy dx is equal to minus 3x squared. I hope you understand that. Now you're going to divide throughout by 3y squared. So dy dx, the derivative, is going to be minus 3x squared divided by 3y squared. Well, you can go ahead and clean this up a bit because that 3 divides throughout. And then you have minus x squared upon y squared. Now, often, not always, but most of the time, if a function is an implicit function like what we have over here, the derivative is also going to be an implicit function. We're going to have a y and an x in there as well most of the time. So this is what you need to remember. So from here, what they do is they will now ask you to find whether it's a tangent or a normal, stuff like that, and they will give you values of x and probably a value of y for you to find the derivative, and you work your way from there. So let's take a question that I have asked learners in a test today. So the very first question deals with a scenario where you have an implicit function, or implicit, that you have to apply implicit differentiation, because you can see that you have got xy, you have a y there, and so on. But now you must be a bit careful here, because this implies that you are going to use, in here you have got 3x times y, which is two functions being multiplied together essentially. So that means once you start differentiating, or once you find the derivative, you are going to use the product rule. Okay, so what we have um, 3, let's just write it here, 3y minus 5y minus 2x squared is equal to 6. So we are going to do dy by dx or d by dx of both sides. So we are going to say d by dx of 3xy minus 5y minus 2x squared is equal to d by dx of 6. Now, this is very easy. On the right hand side, the answer is simply equals to 0. So you have got various terms, so you're going to differentiate each. Okay, the sum of the derivative of terms is the derivative of the sum of the terms, or the differences in that case. But in here, in the first place, you have got a product rule. So what you can do, and there are many ways you can do it. So I will highlight here so that you can know here. I'm going to apply the product rule. So here, I'm going to apply the product rule. And remember, we said everywhere we have a y, you are going to attach dy dx to it. Okay, that second step that I was saying, or that first note here that I was saying, every time you derive y, you must get dy dx on it. Okay, so let's continue then and do so. Right, so using the product rule for 3xy, remember 3x is one of the functions, so the rules say keep the first multiplied by the derivative of the second, d dx of y. Since we have that, we are going to attach something to that. Okay, so in this particular case, we are going to attach dy dx. Let's just write it. I'm going to attach dy dx. Okay, and then you add the second, which is y. Then you multiply that by the derivative of the first d dx, which is 3x. Okay, actually we can continue. So minus 5y, so if you have to derive this, so you will say d by dx of 5y. Remember, you need to attach because you are differentiating with respect to x, so you're going to say dy dx every time when you have y. Okay, minus, now you have d by dx of 2x squared. Of course, that is equal to, I think I can just go ahead and say this is equal to 0 because I've already included that over there. Now let's continue and see what do we have here. So we have got 3x here multiplied by, so you're going to have the derivative of y is just 1. So you have dy dx plus y times the derivative, so plus y times, we're going to put a dot for times the derivative of 3x, which happens to be 3, minus the derivative of 5y. The derivative of 5y in this particular case, you will know that it is just going to be 5, but then you must attach dy dx, okay, minus the derivative of 2x squared is nothing but 4x is equal to 0. So the calculus is pretty much done. It's just now to clear it up a bit. Okay, so let's just write it nicely. So I have got 3x dy dx plus 3y minus 5 dy dx minus 4x. So we need to make dy dx the subject of the formula. Right, so we're going to have 3x dy dx minus 5 dy dx, okay, that is going to equal to 4x. That is, you're going to add 4x to both sides and take away 3y to both sides. So let's just factor out what we have over here. So we have got 3x minus 5, that is dy dx, is equal to 4x minus 3y. Then eventually we should arrive at dy dx is equal to, so you're going to be dividing throughout, you're going to say 4x minus 3y all over 3x minus 5. So this was pretty much something that you were supposed to prove because it was already given. 4x minus 3y upon 3x minus 5. So just go back there and you will see that is definitely what we needed to do so in that question. Okay? Right. Of course, I have a part B to the question. So I'm just going to write my derivative as dy dx is equal to 4x minus 3y all over 3x minus 5. Another thing also that I am going to write down is my original function as I was given 3xy minus 5y minus 2x squared is equal to 6. So I'm just going to write that function down as well, okay, because I will need that function as well. So I'm just going to write that function on this side. It was 3xy minus 5y minus 2x squared is equal to 6. That was the original function that I had. Okay, the implicit function. Right, now they're saying find the equation of the normal to the curve, and they're giving you at the value of x equals to -1. Now the reason why I brought down that if function, the original function, the original equation, is because we need to find the corresponding coordinate of y. Okay, because your gradient is given in terms of x and y, so you need to be substituting a x value as well as a y value. So we need to find what that y value would be. Okay, so we are going to substitute. So we are going to substitute this x equals to -1. Everywhere we have an x, I'm going to substitute it into that for me to calculate what the value of y would be. So that would be 3, -1, y minus 5y minus 2, -1 squared is equal to 6. Okay, this is giving you minus 3y minus 5y. Of course, this is 1, that's -2 is equal to 6. This is -8y is equal to 8. This implies that y would be -1. So the point that I'm going to have, okay, so the point that I'm going to have, my point that I'm having is x is -1 and y also happens to be -1. Right, so this is going to be my x1 in my formula. That's going to be my y1 in my formula. Now, when you calculate the normal, the gradient, we need to find what the gradient is. Okay, so the gradient, now that we have our value of x and y, so dy dx, where x is -1 and y is -1, would be, so we are going to substitute our values of x and our value of y within this. Okay, so we know that x is -1, so is y. Well, if you clean this up and you can go ahead, you're gonna get 1/8. But this is the gradient, but it's not a tangent. We're looking for the normal. So the equation of the normal is y minus y sub 1 is equal to 1 over the gradient negative, and then you have x minus x sub 1. So basically, we'll be substituting this in there. Right, so what do we have? We have got y minus negative 1 is equal to negative 1 over 8. Okay, then you have x minus negative 1. So eventually, I'm going to have y plus 1 is equal to, well, this is nothing but negative 8. Okay, negative 8, and you have x plus 1. This is pretty much done. You can go ahead if you want to give the equation in terms of y equals to mx plus c or mx plus b. Doesn't really matter. This is the final answer because this is the equation of the normal that was required. Okay. Right. Then, of course, this is a question that I've done on implicit differentiation. Stand by for more questions on differentiation so that you can help you prepare for the upcoming exams.